All right, let's talk about scaling. But we're not just going to talk about how systems get bigger. We're going to dive into the strategy behind it all. The really critical choices that architects have to make to take an app from its very first user all the way up to millions. So let's get right into it. So picture this, your app, the one you've poured your heart into, it just hits the jackpot. It gets featured somewhere huge, and all of a sudden, thousands of users are signing up. Like every single minute. I mean, this is the dream, right? But it can also become a nightmare fast. Your single server is just groaning under the load, requests are timing out, and your dream is turning into a full-on success crisis. The real question isn't if you need to scale, it's how you're going to do it without everything catching fire. And that brings us to the core idea of this whole explainer. When you really get down to it, scaling isn't just about throwing more computers at a problem. It's about making really smart, deliberate choices that line up with your business goals, keep costs under control, and, most importantly, don't paint you into an architectural corner down the road. So where does basically every scaling journey begin? Well, almost always it starts with the simplest, most intuitive thing you can do, just making the one server you already have way, way more powerful. This is what we call vertical scaling, or just scaling up. And the best way to think about it is like upgrading your own computer. You know, when your laptop gets slow, you don't go out and buy a second laptop to run alongside it, right? No, you add more RAM or you get a faster processor. You're just making that one single machine stronger. In the cloud, this is as easy as clicking a button to get a bigger server with more CPU cores and a ton more memory. Now, why is this so popular at the beginning? Well, it's simple. You don't have to change your code. You don't have to change your architecture. Everything still lives in one cozy little box, which means you get to avoid the absolute nightmare of distributed systems. Debugging is way easier, and you don't have to worry about your data getting out of sync. This is exactly why a ton of successful apps run as a single monolith for a surprisingly long time. Okay, but here's the catch. You're putting all of your eggs into one very powerful and very, very expensive basket. There's a hard physical limit to how big a single machine can get. And maybe more importantly, if that one super server fails, if it has a problem, if it needs to be rebooted, your entire application goes down with it. There's no backup. The whole service is just offline. And let's talk about cost, because this is where your wallet starts to scream. Scaling up is not linear. A server with, say, 64 cores can easily cost you 5, maybe even 10 times more than an 8-core server. But you almost never get 8 times the performance out of it. The cost curve gets brutally steep really, really quickly. You end up paying a massive premium for those high-end machines. So if that one giant machine has its limits, what's the alternative? Well, now we have to enter a totally new paradigm, the world of scaling out. This is horizontal scaling. So instead of one super strong weightlifter, you now have a whole team of lifters all working together. You're not making one machine bigger. You're just adding more and more machines to your fleet and sticking a load balancer out in front to spread the work across all of them. This is really the fundamental fork in the road. Scaling up is all about bigger nodes, and you do it for simplicity, but you know its growth is finite. Scaling out is about adding more nodes, which gives you incredible elasticity and, theoretically, near infinite growth potential. This is the key trade-off we're looking at. And the advantages here are just massive. This is why every internet skills service you can think of, from Google to Netflix, uses this strategy. You can grow almost without any limits. If one server fails, who cares? The others just pick up the slack. That's fault isolation. You can spin up new servers when traffic is high and shut them down when it's low. And you can place servers all over the world to be closer to your users. But, and this is a huge but, all of this incredible power comes at a price. And that price is the villain of our story today, a massive, and I mean massive, explosion in complexity that people always underestimate. You see, it's actually pretty easy to add more web servers. They're usually stateless. They don't really store any important data between requests. The real catastrophic failures, the ones that take your entire service down for hours, they almost always happen when you try to spread your data across multiple machines. Managing a distributed database is hands down one of the hardest problems in software engineering. All of a sudden, you're wrestling with this whole new class of problems that just didn't even exist before. How do you keep data consistent across machines that are miles apart? What happens if the network between them just breaks? How do you even decide how to split your data up? And what on earth do you do when one tiny piece of data gets way more traffic than all the others? Believe me, these are not easy questions to answer. So, if scaling up is too limited and scaling out is way too complex, what do architects in the real world actually do? Well, they don't choose one or the other. They're smarter than that. They blend them together into a third, much wiser strategy. And we call this diagonal scaling. It's the pragmatic path, it's the common sense path. You start by scaling up your simple single server system for as long as you possibly can. You ride that beautiful simplicity curve. And only when you absolutely have to, when the cost gets too insane or you just hit a performance wall, then you start to strategically, carefully introduce horizontal scaling for specific parts of your system. So this is what that journey usually looks like. You start with one powerful server. The very first horizontal step you take isn't to split the database, no way. It's to add read replicas, which are just copies that can handle some of the traffic. Then maybe you break off a few services, and only much, much later do you take on the hardest problem of all, sharding your database, which means splitting the actual data across multiple machines and then going global. Each step here deliberately introduces complexity, but only when the business case is absolutely undeniable. Which brings us right back to our central theme, doesn't it? These steps, they aren't just technical choices. They're really economic decisions that are just disguised as technical ones.
This table just summarizes the entire conflict perfectly. Vertical scaling is simple, but its cost curve is exponential, and its blast radius is huge. If it fails, everything fails. Horizontal is the total opposite. Linear cost, low blast radius, but crazy high complexity. Diagonal scaling is that pragmatic balance right in the middle, optimizing all the trade-offs across the board.
And this chart just visually hammers that point home. Scaling the easy part, that stateless compute layer, that's a solved problem. The real difficulty, the part that requires a ton of careful thought, is managing state. And databases are, without a doubt, the absolute hardest challenge of them all. So let's wrap this up with the core lessons. If you remember nothing else, remember this. Your scaling strategy is really a bet on your future growth. Don't be too quick to ditch vertical scaling. It can buy you so much precious time and speed. But know this, once you shard your data horizontally, it is almost impossible to go back. For most businesses, the safest, most effective path is that diagonal one. And always, always remember, your database will ultimately decide just how far you can possibly scale.
So, in the end, scaling is a discipline. It is not about the reactive, panicked act of just adding more servers. It is about the strategic choice of when to introduce the complexity of distribution, how you're going to wrangle that beast we call distributed state, and how to do it all in a way that perfectly balances cost, speed, and reliability. Now that is the true journey from one user to millions.